Hey, Chad here with LearnMixedReality.com and ChadCarr.net. I'm glad you're back with me as we continue this series on creating a game, a mixed reality game, from the beginning to the end. And last week, in the last session, we actually worked on creating the animation. And so in the scene with our item animation, we can hit play and actually see the animations going. And in our animator here with our parameter, our in-motion parameter that we set up, if we actually play the game, we can see the default animation, this item default is just continually playing. If I select in motion, then it will transition over to this item animation state. And if I uncheck in motion, it will finish that state and come back to item default. And those all happen because of our states, right? So that's what we set up last time. What we're going to do today, I'm going to stop playing this game. What we're going to do today is actually hook up this in motion to code. That way we can control when the animation should start and how it should work actually through our code. Let's go over here to Visual Studio. Now I'm going to right click on my scripts and add a new class. I'm going to call it Animations. I'm going to get rid of the namespace here and make it a public class, Animations. And this is going to have an animator object. So I'm going to hit Control Dot to actually bring in using the Unity engine here. Animator. This class is also going to need a game object, which is going to be our actual animated object. I'm going to create a constructor here, and inside of our constructor we're actually going to pass in, let our game controller pass in the object that needs to be animated. So it's going to be game object, animated object. And then we'll just simply say this dot animated object is equal to the animated object passed in. So let's go and stub out the methods that we want the game controller to be able to call here. So we're going to create a method called animate items, and we want another one called stop animations. So let's jump to the game controller class itself. And since we used find by tag when we were setting up our text objects, this time we're just going to do it as a serialized field, just to show a couple different ways to do it. So I'm going to create another serialized field here, and it's going to be a private game object, animated object, and we're going to be able to assign that here. Likewise, I'm going to need another private object we can work with, and it's going to be animations for our class. We'll just call it animations. And then in our awake, right after we initialize our core logic, let's go and initialize our animations by passing in that animated object. All right? So we're going to save this. I'm going to go back to Unity, let it recompile the scripts. We're going to click on the game controller, and on the game controller we'll now see we have an animated object. Now we started the animation in the last session using table, and since we did that, I'm going to drag table here on top of animated object. Now again, we could have done the same thing we did with the text and come in here and create a brand new tag, assign the tag for animated object. I'm doing it this way in case we ever want to have multiple animated objects and reuse the animated class and maybe rename these fields. So it can be done a bunch of different ways. But right now we have associated our table, which has the animation on the individual items, to our animated object. And then back inside of our controller, when we first initialize the game controller, we're going to then pass in that animated object to the animations class. So in our start turn method, we already had a comment where we wanted to animate our items, right? So this is where we want to shuffle the items. And so we want to just call animations.animate items is what we want to do here. Okay. So I'll get rid of that comment. And we likewise want to actually, stop the animation at the appropriate time. We'll do that when the item is reset. Once the reset's actually completed here in this event, once the reset has been done, at that point we want to go ahead and stop our animations. Alright, so we've hooked up the methods that we've already set up here. So let's actually make these methods do something. Let's make it work. Well, we know in the animate items method, we ultimately want to make this parameter in motion, make that true. Okay? And the way you do that is you have to talk to an animator object. So this animator we have up here, we'd actually say animator dot set bool, and then you have to give it some ID and set it to whatever value you want. And since we're animating it, we do want it to be in motion. So in fact, that's in motion is the key. So we're going to set the Boolean of in motion to true. Likewise, when we want to stop the animation, we simply want to set that same animator Boolean in motion, but we want to set it to false. Now, last time we would start getting rid of some of the magic strings using our rest thing. So let's do this again. In our resource file here, I'm just going to say public static read only string in motion is equal to in motion. And now back in our animations, instead of using this magic string, we can say resource.inMotion. Now, you might, depending on what you're doing, you might would actually have two different files. You might want to have one that's really like for localization, like score, high score, and X. If you want this to be different languages, then you could set it this way and actually send this out to a company to translate the bits. And then your internal IDs would actually be in a different file. So you could do that. You could also load this more, the ones that are language dependent, into like a comma delimited file or an actual true resource file, depending on what you want to do. For now, I'm only concerned about a single language, English. So I'm just having all my magic strings, if you will, in this resource static class. And that's all we need to do to actually animate the object, is call animators, set the Boolean parameter of inMotion to true, set the animator's Boolean parameter of inMotion to false to stop them. But we've never actually assigned this animator, and we need to do that. And since the calling class could create this object during the awake or during the start, we don't know exactly when they're going to do it. We could, in theory, just come in here and say, animator is equal to animated object dot get component and get the animator of that component, right? We could do that. The problem is, if this gets called in the awake, that might cause issues. So instead, we're going to just make a whole other method here that needs to be called by our, in this case, game controller. We'll just call it assign animators. And that way, even if the caller wants to call this in the awake, they can do this in the start or whenever it is, as long as they assign this before they actually try to animate the objects. So let's go back to our game controller and call assign animators. And I'm going to do it in our start method. I'm going to say animations assign animators. So when we wake up, we're actually going to instantiate a new animations object, passing in the animated object that's associated to our game controller's object. And then when we actually call start, is we're going to assign that animator. Of course, we know that by that point, that object is ready to roll. And then inside of our start turn is we're going to animate the items. And on our complete, reset complete, is we're going to stop the animations. All right, so let's jump back here to Unity. And let's look at our item animation. And we see the loop time is checked. And we'll leave that alone for now. So let's just go and play and see if our animation is hooked up correctly. So we can tap this, tap that, and already something's wrong because this should have been animating when we first started. And right here it should be animating, and it's not. And just to confirm, if we check in motion here, we can see the animation happen. And if we uncheck it, it stops. So we're either not setting this correctly, or what I believe is happening is we're not really giving it a chance to stay set. So let's take a look at our code. And here under start turn, as soon as we start the turn and we animate the items, the very next thing we're doing is resetting the items. And of course, in the reset items, as soon as the reset's complete, we're going to stop the animation. So we're not really giving it any time to do the animation. So I want to move this into its own method. So I'm going to say public void reset items. And I'm going to move that down here to reset items. Now that I do that, we're obviously not going to call this guy, so we've kind of broken our logic, but that's okay. I just want to confirm that what I'm thinking is accurate. So I'm going to hit play, and I would expect that our things to be animating immediately once Unity responds here. Okay, and sure enough, right off the bat, everything is animating. And it's going to keep animating because we never are resetting the items. So I could uncheck that box and make it stop. But that means that my thought process here was accurate, that it was animating the items, but then immediately calling core logic reset items, which was in turn stopping the animation. So what we want to have happen instead is for the animation to play until it's done with the animation, and then call this reset items. That's the whole reason why we're kind of having these events and making the client, in this case our game controller, call our core logic's reset items. Because if the core logic just reset it, then the game itself couldn't determine, when the item should be reset, kind of when the next turn should start. And the whole point here is so that the game can have full control over how long animation should be, what animation should be there, and everything else. And if we weren't doing any animations, the game can do just like it did before and simply call reset items immediately on the start turn. But in this case here, we want to actually animate the items. Later we'll actually add some sounds. But we want to add the animation here. And when it's done playing its animation cycle, then at that point we want to kick off the reset items. Okay. So in order to do that, we actually need to make an animations events class, because what we ultimately want to do is in our animation, for our table animation here under item animation, we were adding keyframes in the last session, But now we want to actually add in an event. So I'm going to drag our timeline here to our very last keyframe, meaning that when we're here, we're at the end here, I'm going to add in an event. And it's saying there's no function selected because there is no function here. If I select the actual item animation and click on the event here, so the way I went there the first time was by clicking on the object I was animating, which was table, and selecting item animation, and then clicking on the event. But there's no function defined, and there's nothing I can actually select. If I go to item animation here, and then click on that event, I can actually type in the function that I want it to call. But I don't actually want to do it here. Instead, I do want it to be associated to my table, my very specific one, because maybe the animation in this one I want to have called, but if I wanted something, this other animation, something else, in our example really doesn't make sense. But if I wanted to have a different animation, a different set of objects that ran this animation and kicked off a totally different event, I want to have that flexibility. So what I'm going to do is create animation events and then assign that to this table. And when I do, then I will actually be able to select the methods that are inside that event. So instead of just keep talking about it, let's actually do it. So under scripts here, I'm going to right click, because this is going to need to be a mono behavior. So I'm going to right click and say create C# script, and I'm going to call it animation events. And we'll open that up in Visual Studio and let the solution reload. Our mono behavior is not being recognized, and so what I'm going to do is go to my references like I've done before, and select Microsoft C#, change it to copy local, compile it. We see we actually have it back, but I'm going to take it back to local to true and recompile. And now Visual Studio is happy understanding what a mono behavior is. So we'll get rid of the start and the update. And I'm going to create a function called reset item. And notice this is not public. It's not a public method here. And I'll explain why I'm pointing that out here in just a second. But I'm going to call the game controller's instance and then call reset items. Okay, so I called this method reset item just because I just want to make sure it's clear of what's getting called from where. So we have this animation events. From the animation events, we've created a method called reset item. In this reset item, we're going to call our game controller's reset items, right? So we're going to call this guy. That's why it's public, so we can get access to him. And then over here in Unity, we're going to drag the animation events onto our table. It hasn't actually compiled yet, so let it finish compiling. Now I'm going to drag it onto the table. All right, so click on table, and sure enough, now there's our animation events. Now with table selected, item animation, and then click on this, now we should have this reset item. Notice it's a singular because it's grabbing that reset item from our animation events, even though it's not even public. It's fine either way. And what we're doing is when the animation is done, this method is going to get called, and we can do whatever we want to. What we're doing now is actually just calling back to our game controller's instance reset items. And of course, that's then going to call our core logic reset items. And by doing that, a little bit of legwork there, I'm going to save the scene and save the project. We'll hit play. And now that the animation is done, we came back. We already stopped. We didn't have to do anything. It just stopped. I'm going to select this one. And the animation's starting automatically. Animation starting again. I've selected it right on the first try 3 times in a row, but not the 4th time. 4th time I get a strike. But the animation's working regardless whether I get a strike or I make it, because it's just a matter of the turn is over. And again, you can actually see over here how it's going from I am default to I am animation and then back to default when the turn's over. And there's our last strike. And the game is reset with a shuffle. And so our animation is actually working by using the in motion. Property is getting set correctly. And when it gets set, it's transitioning to our animation. And when the animation is done, it kicks off the event called reset item. And the reset item is calling our core logic's reset items, and of course that's then calling, I say a core logic, it's actually calling our game controllers reset items, which is then finally calling our core logic reset items. So hopefully that was clear. If you've never done this before, it can be a little confusing the first time, so if you need to kind of rewatch this, feel free. But this is the best way I found to explain it from beginning to end of working with a particular event at some point in the animation. And again, I could actually make, add an event at any point in the process here, right? So if I wanted to, whatever reason, add an event right there, I could, and then select something I want to happen there. Maybe it's a particular sound I want to play at a particular time. This is a way that you can make that happen. Now, if you add an event and you don't want it there, you just simply hit the delete key when you have it selected, and that event will go away. All right. Well, that's going to wrap up this session where we actually wrote code to talk to our animations and hooked that logic up. Now we're coming towards the end. We're coming towards the end of the series. We still have some work to do. We need to create some sounds. We're going to create a particle effects, and we'll do some other, just kind of wrap up some cleanup as well. But next session, we're going to be hooking up our sounds. So we hooked up the animations in this session. We created the animations last session, hooked them up in this session. And next session, we're going to actually create the sounds. So we'll have a sound for when you make a match, when you don't make a match, and when the items are shuffling around on the table. So I hope you'll join me for that. If you enjoyed this tutorial, then I hope you will click that like button. If you didn't like it, go ahead and hit that dislike button. That way I'll know whether I should be doing these or not. And if you did like it and you want to see more of this, then by all means hit that subscribe button. I release videos every single week. And it's always around either HoloLens development or these immersive headsets. In general, it's mixed reality development. So if you take an interest in this, then by all means hit that subscribe button. I hope you have a fantastic week, and I'll see you in the next video.